So, equations of parabolas. Given the quadratic function y equals -1/2 x plus 3 quantity squared plus 8. Okay, so we should know all about that now. So which way does it open?
Down.
Opens down. Because why? Yeah, so a is less than 0. What's the vertical stretch factor? 1/2. Right, that's the absolute value of a. Whether the graph is narrower or wider? Wider. The coordinates of the vertex? -3, 8. Excellent. The equation of the axis of symmetry? X equals -3. The range? Which way does it open? So y is less than or equal to 8. The max min y value and the value when it occurs? Max y value of 8 when x equals 3. -3, sorry. The X-Intercepts. Okay. Might require a smidge of work. So. So here's how we're going to solve this, right? We're going to isolate the thing that's squared. So we're going to move the -8 over. We're going to multiply both sides by -1/2. Sorry, by -2 to clear out the -1/2. Right? We could divide both sides by -1/2, but I don't like dividing by fractions. So 16 is equal to x plus 3 squared. So x plus 3 is equal to plus or minus 4. So I just reverse the sides and taken the square root of both sides. And then x is -3 plus or minus 4. So x is -3 minus 4, which is -7. And x is -3 plus 4, which is 1. So the x-intercepts, -7 and 1. And the y-intercept. So to get the y-intercept, same deal, right? We're going to start with the equation. So I like to rewrite it. And the y-intercept occurs when what? When x equals 0, right? Okay, so we're going to put in a 0 for x. Okay, plus u. So the y-intercept is 7 over 2, or minus 6. Plus u. All right, all good? There's your review. Now something new. Write the equation of a quadratic function with no x-intercept. All right, it's not all that new. So what are the characteristics, right? Like, what do we need? Right, so if a is greater than 0, q is greater than 0, so, y equals x squared plus 2, right? And, keep it simple, right? Like, why not? Or what if I did this? Then what would I need to put? Minus anything, right? Just minus 4. 1 x-intercept. It's about as easy as it gets, right? Y equals x squared. Okay. What's the characteristic that I really need? So what's it important that Q is equal to 0, right? So that we're not moving up or down. Two X-intercepts. There you go. Nice and easy. Take something that has one X-intercept and move it up or down, depending on which way it opens, right? Okay. So there are infinitely many answers, right? But try and keep it reasonably simple. You know, you don't have to go all complicated. Y equals 7x squared minus 23x plus 12. Okay, the graph of y equals x squared was transformed to the graph of y equals negative 3x plus 5 pony squared minus 2. The point negative 3, 9 lies on the graph of y equals x squared. Determine its image point after the transformation. I thought we were doing new stuff today. It's like not all that new stuff. Okay, you guys aren't on much room, do you? Okay, so you've got like a little bit of space like this, right? All right, so let's go across. So number one, let's do the transformations. So you need to describe these. Okay, so number one, what's the first thing going on? Vertical stretch by a factor of 3. Okay, so Vs by 3. Number two. Reflect in x axis. Number three. And number four. Okay, so we stretch, we reflect, and then the translations, right? And generally I do horizontal, vertical. You don't have to, you can do vertical, horizontal. Okay, well, we've listed those, so let's take our point, which was what? Negative 3, 9. And let's just go along here. And so negative 3, 9 becomes what? For this vertical stretch. Negative 3, 27. Which becomes what? Which becomes what? Which becomes what? Okay, there we go, right? Easy peasy. So list the transformations, right? Write it out in English, okay? What's going on here, okay? And then just follow underneath, right? Or beside. You don't have space to go beside, so we're just going across this way, right? We start with negative 3, 9. A vertical stretch by a factor of 3 triples the y coordinate, right? Becomes 27. Reflect in the x. Now it's underneath. It's negative 27. Go left 5 and down 2, and there we are. Okay. Writing equations. Write all equations in vertex form. So this is vertex form, right? Because what's the vertex? PQ, right? So from this form of the equation, we get the vertex, right? It's there for the taking. You just have to look at it. So determine the equation of the parabola. Notice it says the parabola, right? Not a parabola, right? A parabola implies there's some family of parabolas that might have this. The parabola says there is one parabola that satisfies this. So determine the equation of the parabola. So let's start with y equals a. Well, I like to start with the formula, right? Because you know, you're going to get a formula sheet and it's going to list these things on it. But by writing this down, what you're basically communicating to everybody is, all right, I know that I'm going to be using the vertex form of the parabola equation, right? Because there are other forms that we're going to study. And then I like to say this. Okay, so that means y equals a x minus 3 squared minus 5. So I'm going to put in the p and the q. Okay, now what? Yeah, so they gave us an x and a y, right? So what don't we know? We don't know a. But if we put x and y in there, all we're going to have is that one variable we can solve for it, right? So now we substitute in the point, negative 13, and make sure you get the right, because it's actually this goes there and that goes there. So a, 1 minus 3 quantity squared minus 5. Okay, so solve that, get a. And once you've got a, rewrite this line with your value of a. And then you'll have the equation. Okay, so work on that, don't look up. I'll do it up here. Okay, so how's that? Yes? No? If I made a mistake, I didn't try to, but at times I'm gonna try and I'm not gonna try. I'm gonna make some mistakes occasionally, and then I'd like you to look up and say, I'm wrong, and then say, no, you're wrong. Just figure it out. Okay. So on those occasions when I don't do it on purpose, we'll get it correct, right? Somebody will say, Okay, any questions on that one? Right, so we look at that question, we say, oh, they gave us the vertex, so I'm going to use vertex form. Here it is, right? Here's my formula. Right, and what that tells me when I'm marking this is, yeah, okay, you started with the right formula, right? If it starts with a different formula, it's like, yeah, this thing is probably not going to be solved correctly, right? But started with the formula. I substitute in what I know, then I put the point in, okay, and then the reason I don't, like, you could go straight to here, right? Because you could say, well, I know the P and the Q and the X and the Y. I like this because this is going to match this, right? Like, I'm going to take this and write it down here, but only with the value of A. So I'm saying, hey, this is what I'm going for. And there I am. Yeah. Okay, determine the equation of the parabola shown. So first thing, what? We got to figure out the vertex, which is where? 2, -8. Now, what we need is another point on the parabola, right? And that point is 3, -5, right? Because we don't know the stretch factor, except we do, it's 3. But so we don't know the stretch factor. So really, I could just write this out, right? Y equals 3, x minus 2, quantity squared minus 8. Boom, done, right? But that's not determining, right? I wouldn't be showing any work says determine, you got to show work. Okay. So, what am I starting with? Formula. Okay, start with formula, right? Again, that just shows everybody, anybody. Somebody asks you, hey, can I see your answer to number, whatever, and they look at it, you start with the formula, they say, oh, okay, we're starting with the vertex formula. Now what? Well, we had to find the vertex, so we're just going to plug that in. Okay, because I know my final answer is going to look like this, only it'll actually have the value of A. Now, we found an xy, and it doesn't matter, it could be this one here. It could be 4, 4. So, maybe I want to use 4, 4. Two, 4, I'm going to... And, oh, shock, A is 3. Okay, but we've determined it this time, right? We have shown work to justify why A is 3. So that's basically the scenario, right? If you have the vertex and a point, this is what you do. You start with the vertex form of the equation, you plug the vertex in, you then substitute in the point, x, y, you solve for A, you state your answer. Now, if you want, I mean, especially given the graph, you could graph this on your graphing calculator and just say, does it look like that? Yeah, okay, good. All right, look, I got it. Okay. Determine the equation of the problem with range. Ooh. Y is greater than or equal to -6 and x-intercepts at -5, 3. What would be a good starting place for this? What might you want to do? I'm going to draw a picture. What does this thing look like? Okay, so I got -6 sitting down here. I have x-intercepts at -5 and 3. So, where's the axis of symmetry? Yeah, you were closer, Henry. So where's the axis of symmetry?
-1.
Okay, how'd you get that?
Well, it's 4 away from the 3 and 4 away from the -5.
Yeah. So we got to go halfway, right? So if we have 2 points on a horizontal line, the axis of symmetry is always going to be right between them, right? So A of S, x equals -5 plus 3 over 2, okay, which is -1. So here's my axis of symmetry. And then where's my vertex? Well, if your minimum point, right, minimum, so -1, -6. Okay, there's your minimum, right? Because the range is y is greater than or equal to, which says this is the minimum. A lot of paper. Okay, you got the vertex, you got a point, you do it. Right, and fractions, not decimals. Okay, fractions, not decimals. All right, so when we look at this, we're given information, right? We know the vertex, the y-coordinate of the vertex is -6. Right? We know it opens up because it can't be down to -6 there and end up going through the x-axis unless you're going up. Which just tells us that our A is going to be positive, right? That's just a look back at the end. Did I get a positive value for A? Yeah, good, because it opens up. I should have a positive value for A. What points do I have? We don't really think about an x-intercept as a point, right? But it's the point 3, 0, or -5, 0. If you get the y-intercept, it's the point 0, comma, whatever the y value is. Okay. Remember, intercepts are just numbers. The x-intercepts are -5 and 3, but the parabola passes through the point 3, 0, or through the point -5, 0. Right? And I can use either one of them. Right? Because 3 plus 1 is 4, squared is 16. -5 plus 1 is -4, squared is 16. Okay, again, symmetry. Okay, questions on this? All right, we're good. Copied down. The equation of the axis of symmetry of the graph of a quadratic function is x equals -1, and the graph passes through the points 0, 3, and -3, 9. Determine the equation of the function. Okay, so what do we do? Yeah, draw a picture, right? I like to see, right? What am I dealing with? Does it open up or down? That's really not going to affect, because we're doing this algebraically, but whether it opens up or down means when I finally figure out A, I can say, maybe I made a mistake on the sign of that thing, right? Because having drawn this. Okay, so what do we got? 0, 3, -3, 9. And the axis of symmetry is x equals -1. Does it open up or down? Actually, I think I could make a case for either, right? I mean, you could go like this and this, or you could start up here and go through there. So, don't know too much yet. Okay, well, what do we know? What's P? -1. What's Q? Don't know. What's A? Don't know. Got two things we don't know. What's that lead us to? System of equations, right? Two equations and two unknowns. All right, so what do we got? Y equals A. So let's start with the formula. So I have two xy's, right? I got a 0, 3, so I've got an xy there, and I've got -3, 9, and I got an xy there, and I know P. What I don't know is A and Q. So we're going to get two equations, right? One using the point 0, 3. Okay, so let's do that. 3 is equal to A x plus 1, right? Because I'm putting in the P value, squared plus Q. My x should be 0, right? I was just looking at that and saying, wow, this is going to get really ugly because now I'm going to have some quadratic. Thank you. Okay, so 3 is equal to A plus Q. There's one equation, right? Whatever A and Q are, they're going to add up to 3. Equation number 2. Okay, equation number 2. What do we got? 9 is equal to A bracket -3 plus 1 squared plus Q. Okay, so we replaced xy with -3, 9. So 9 is equal to 4A plus Q. So, how do we solve this? Let's do this. 4A plus Q equals 9. A plus Q equals 3. We'll solve by subtraction, right? Yeah. Elimination method, because we can just get rid of the Q, right? So 3A is equal to 6, and A is equal to 2. If A is equal to 2, then what's Q? Now, I'll let you make that big leap, right? Since we know that A plus Q is equal to 3, you know, once you've got A or Q, I'll let you just state the other one, right? There's no big deal. All right, so actually it does open up, and it's going to be like here, and then go like this, and this. Okay, so the equation is y is equal to 2x plus 1 squared plus 1. Okay, now if you want to check that, if I put a 0 in here, 0 plus 1 is 1, squared is 1, times 2 is 2, plus 1 is 3, I get 0, 3. And if I put a -3 in here, -3 plus 1 is -2, squared is 4, times 2 is 8, plus 1 is 9. Right? It's always a good idea to just go and check it, right? You may have made a mistake in, somewhere in there. So you could go back and you just make sure that those points are on this. Or you could graph this, then go into the table. You look in the table, when x is 0, you should see a 3. When x is negative 3, you should see a 9. And that's a good way of checking. Okay, or you could graph it and just kind of trace along and just say, look, yeah, it's 0, 3, it's negative 3, 9. Okay, questions? All right, so this is the harder one, right? Because you're solving a system. A cable that supports a suspension bridge is parabolic. Not true, it's a catenary. But we're going to say it's parabolic. The horizontal distance between the ends of the cable is 140 meters. Actually, I think when you hang weight from it, it does become parabolic. The midpoint of the cable is 14 meters below each end of the cable. Determine an equation to model the cable if the vertex is at 0, 0. Okay, so what we're going to do, now you notice we're going to get different equations for this, and it all just depends on where your vertex is, right? So the vertex is at 0, 0, tells us, well, we got to go here and here. So there's 0, 0. Okay, I got the vertex. I need a point on the graph. What is this point here? How far out?
70.
70. How high up? What's this point here? Okay. Right? Based on the diagram, it's 140 meters end to end, then it's 70 meters from the middle out. Okay, well, usual, right? Zero, zero is nice, right? Because then it's just y equals ax squared, right? No p, no q, right? X minus 0 squared is just 0. And then we just plug in, so 14 is equal to a times 70 squared. 14 is 4900a, and a will be 14 over 4900, which I think is like 7 over 2450. Is that reduced? No, 2 over 700, 1 over 350 ultimately. So the equation is y is equal to 1 over 350 x squared. Now, somebody's chosen to put the vertex on the left end of, the vertex is on the x-axis, and the left end of the cable is on the y-axis. So the left end is on there, and the vertex is here. So vertex is on x-axis, left end of cable is on y-axis. So what are the coordinates of the vertex? 70, 0, right? It's halfway, right? It's 140 meters, but vertex is in the middle. Okay, so 70, 0. And what's a point on, what's this point? 140 and 14. And what's this point? 0, 14. Okay, so I don't know about you, but I'm picking the point 0, 14, not 140, 14, right? Okay, y equals a, x minus p quantity squared plus q. Y is equal to a. Where's the vertex? 70, 0, so x minus 70 squared plus q. Plug in an xy, so 14 is equal to a. 0 minus 70 squared plus q is 0 plus 0. 14 is 4900a. A is 14 over 4900, which is 1 over 350. 1 over 350 x minus 70 squared. And you don't need to write plus 0, right? Why is the a value the same? Yeah, it's the same shape, right? What does a really tell you? Direction of opening and the shape, right? You know, narrower or wider. Is this narrower or wider than your standard parabola? Wider, yeah. They're always, in real life, they're gonna always, parabolas are gonna always be wider, right? Because think about y equals x squared, right? That gets up pretty quick there. You think, well, hey, I saw this arch, you know, you don't see any arches that are like that, right there. Nicely. Okay. So your a value is generally going to be a number like 1 over 350 or something. And the left end of the cable is at 0, 0. So where's the vertex?
0,
70, halfway, right? And that's 0, negative 14. Okay, do it. And where's this end, right? This is just 140, 0. Don't be surprised with your a value. Okay, so a's got to be the same, right? Because the shape of this thing didn't change. Okay, I mean, no matter where it's all just based on your frame of reference, right? Where's the vertex? Where's the best place to put the vertex? Looking at A, B, and C. Where's the best place to put the vertex? Look at the work you had to do in A and B and C and say, well, it's easiest to do this. Put it at 0, 0. Right? Then you're not worried about P and Q, right? There's no values of P and Q. 0, 0, boom. So it's just what? Y equals ax squared. Okay, good. Now all I got to do is figure out a point on it, given that the vertex is there. I just need to get a point, plug it in, get the a value, right? You're not worried about P and Q. All right, but you could be asked questions where the vertex is here or there or somewhere else. That's it.